Hello and welcome to lesson 6.9 for CTM, where we will be reviewing, for most of you that have taken algebra before at least, the quadratic formula and factoring. We're going to talk about both those things here and how we can use those things to solve some real-life problems. We won't do so many real-life applications here, but there are a lot of real-life applications to these kinds of problems. We'll need to know these terms by the end of the lesson here, and make sure you're using those extra examples. There's 12 in the book, using those extra examples in the book. We're not going to do nearly that many here, but we're going to try to hit at least one of each type. So some of you should, if you're a CTM student of mine, you should definitely know this stuff already, but it may have been a little while since we've done factoring, since we've done quadratic formula stuff. So we're going to be reviewing that here. So let's multiply to start here. Leave a little bit of space above here so that we have enough room to write something, squeeze something in there. Well, let's multiply 4x minus 3, that binomial right there, times this binomial right here, x plus 2. So let's multiply this out. What's that look like? I'm just going to put an equal sign right here because it's going to equal something over here. So in our different color, let's connect these two together, and let's put an f above those two. So this is standing for something. Maybe you remember what that something is. We'll get to that in a second. These two, connect that and write an O next to that one. These two, connect those, write an I. Oh, I see where you're going with this, Mr. Wagner. And we got F, O, I, and then these two, connect those two, put an L with that. This is the FOIL method. So the FOIL method of multiplying or expanding binomials. We would have the F part, the first part, 4x times x, is 4x squared. The outside or outer parts, 4x times 2, is going to be plus 8x right there. This will be minus 3 times an x will be minus 3x. And then the last would be negative 3 times positive 2. That's negative 6. So why are we doing this in the first place? Well, we need to multiply everything here, every piece here, by every piece here when we have something written out like this. And FOIL always does that for us. It gets us all the pieces here times all the pieces over here without missing any. So over here, let's put the corresponding letters. That was the F, this was the O, this was the I, and this was the L. So first outer, inner, and last, or first outside, inside, and last. And if we combine like terms here, the x's can come together, and that gives us a final answer. This is a trinomial because it's got 3 parts here. These two were 2 separate binomials. They've got 2 parts that we couldn't combine together. But this being a trinomial, this trinomial is our final answer. So we FOILed it out, we combined like terms, and we got 4x squared plus 5x minus 6. Let's check out a second example. So multiplying it, that's the easier part, the easier thing to do, I think. But sometimes we start with something like this, and we have to factor it back into something like this. This is a little harder. But this first method, or this first style that we have, will be one of the easier versions. We've got x squared plus 12x minus 28. So if you like writing the factors out, if that helps you, you could write the factors out of 28. You could do that off to the side. I don't think it's really necessary, though, for most of us at least. I don't think we'll need to do that. But over here, let's make an x. I call this a magic x. So I want you to write this. If this helps you later, go ahead and use this later. If you can do this kind of in your head or trial and error without drawing something like this, that's fine by me too. So this is just something that I think will be helpful for you later. You're going to put the last number right here, negative 28. You're going to put the middle coefficient down here, positive 12. So just the 12 goes down here. This number represents, the positive 12 represents the sum of the terms. When we FOIL, notice the outside and inside last, we're going to put those, or we're going to put those together, and we're going to get 5x in this case. The last is the product of those last two numbers. So the product of the last two numbers going here. The sum of the inside and outside terms is going here. The sum of those terms would be positive 12. And so what factors, what numbers, this is what we're doing with all this, what numbers here are going to multiply negative 28 but add to 12. So this right here, let me finish this thought. This was the sum. So these values are the sum. and this right here is the product. So the sum and the product, and if we're looking at that here, that's where these two numbers came from. So that's the sum right there, and that's the product right there. So think of two numbers that are going to multiply to 28. Well, we could use 1 and 28, but that's not going to help us. There's no way to combine that, even with negatives, to make this a sum of 12. So we could have that, but that's not going to work. We could have 2 and 14. That sounds interesting. Let's do that, because I can think of a way that I could write 2 and 14 where I could add them together if one of them was negative and get a sum of positive 12. So if I made this negative, I'd have negative 2 times positive 14 would in fact be negative 28, but it would also be negative 2 plus 14 is positive 12. That's then the combination that I'm looking for. So this right here is going to equal, if I factor it out, factoring a trinomial always means we're trying to factor it out into two binomials to separate it out. So since this number is just a 1 out in front here, we can assume that these are just going to be x and x. X times x would give me x squared. That would be my first piece right there. And then I would have, for the inside and outside parts, that's going to be these two numbers right here. So let's circle those in our different color. These two numbers are going to get filled in right here and right here. The order does not make a difference because the x and the x, it's the same thing here and here. So I'm going to I'm going to just fill in right here a positive 14 and a negative 2. If I FOIL that back out, if I think of foiling that back out, this would be 14x, this would be negative 2x. Putting those two things together gives me positive 12x, like I would expect. Or like I should expect if I did it right. So I got that, I foiled it back out, oh my gosh, I can't talk. I foiled it back out in my head, inside and outside came together to get positive 12. We already saw that was going to work over here though with the magic x. So this is the easier style when there's no coefficient in front of the x squared, no a value there. We have ax squared plus bx plus c is the general form for any quadratic equation. That's what these are. These are quadratic equations. If we graph these, they would be parabolas. But now let's throw a little twist in there. So 5x squared minus 23x plus 24. So again, it's a trinomial. We're going to try to factor it into two binomials. So something's going to go here, plus or minus, a plus or minus over here, something over here with some coefficients. So I want you to think of now, let's write this down, the factors of, and in our different color here, factors of, well, this first number 5, because I know my first terms multiplied together, better give me 5x squared, otherwise I don't have the right thing to start. So I have to multiply something times something to get 5x squared, and so I know my combinations that would work for 5, it's just 1 and 5. Maybe it's going to be 5 and 1 instead of 1 and 5, but it has to be those two numbers here and here or flip-flopped. And I'm also going to have factors of 24, so there's a lot of possibilities for that. 1 and 24, 2 and 12, 3 and 8, and 4 and 6. And those might be flip-flopped as well, so kind of all just depends on what's going to work. So with this, let's make a little note off to the side here. When there is a number, or a coefficient, in other words, a number in front of the x squared parts, I think the easiest way, there are some algorithms, some techniques that always work, but I think they're, in my opinion, almost more confusing than just using trial and error. I think they are a little more confusing. They're hard to remember, the algorithm that always works. So I think it's better if we just use trial and error, at least for the kinds of problems that we're going to see. I'm not going to give you a problem where you have like 20 different factor combinations for a number here and 10 different factor combinations for a number here. Don't expect to see that. So this trial and error method will work pretty well with the ones we have to tackle here. So use trial and error with different factor combinations. Until you find the right one. And so I know it's either got to be 1x times 5x or 5x times 1x. It's not really going to make a difference where I put those two things. So I'm going to just put them here and here. But then with that established, I know that I'm going to have a certain factor combination here and here, that when I put these two together and these two together, it gives me this term. So right now, I just want you to draw this in with a different color. Draw these two coming together. This is going to be my inside part, and draw these two coming together, my outside part, and then just put your pencil down for a moment. I just want you to listen. We're going to use trial and error here. You're going to see me go through this. So I'm going to be erasing some things here potentially. If I don't get the right combination, I'm going to have to erase some things. And so let's see what I got. I know it has to multiply to positive 24, but it has to add together to get negative 23. So let's just try the first thing I see here. I know that the only way to get a positive here but a negative here is if these were both negative signs. So I can at least establish that much. That has to be true. That's the only possibility, only way to get a positive product but a negative sum. So these values, if I put in a 1 and a 24, don't write that down yet. Let's see if it works. If I put these two things together, I would have, again, don't write this down, you're just listening, you'd have negative 1x, and these two parts, whoa, that's going to be huge, negative 120x right there. If I put those two things together, I definitely don't get negative 23, I get negative 121. And so, sorry, that didn't work out for us. That wasn't so good. So we're going to erase that. Trial and error here. So that didn't work out. If I flip-flopped those, and I put 24 here, and 1 over here, I'd get a little closer. I'd have 24x, and this part would be negative 5x, so negative 24x, negative 5x would make negative 29x. Close, but no cigar. So let's try a different combination. I could try 2 and 12. Let's do that next. I'll try 2 and 12. This would be negative 2x, and this would be negative 60x. But again, sorry, that doesn't work. You put those two things together, you get negative 62, which is not negative 23. If I flip-flopped those things, I would get, so I have 12 here and 2 here. This would be negative 12x and negative 10x. Oh, you might say, oh, Mr. Wagner, that's so close. I think that's good enough. No, no, no. We got to have exactly negative 23x. We have negative 22x by doing that. So let's try a different combination. Let's try 3 and 8 and see what we got. See if that is going to work. So let's put a 3 here and an 8 here. If I do that, I have negative 3x. I'd have negative, not 8x, but negative 40x. There we go. Together, that makes negative 20 or negative 43x, not negative 23x. So sorry, did not work. Try again. Keep trying. If I'm going to try 8 and 3 the other way, it would look like this. Negative 8x, man, it just seems like it's, oh wait, no, it's going to work. There we go. Boom, there it is, negative 23x. So I'll put those two things together. Let's now put that in our different color, that part. So this was the right thing, negative 8x for the inside part and negative 15x for the outside part. Put these two things together. These two things are going to add to negative 23x, just like we expected that it would, or it should. It should add to negative 23x. If you multiply 8 times 3, negative 8 times negative 3, you get positive 24. If you multiply 5x times x, you'll get 5x squared. So if you FOIL it back out, you can check your answer and you get the right thing. So let's just make a little note under there in our different color. We can check this, at least check it mentally with FOIL. Now you might ask, Mr. Wagner, do I have to keep writing those things in and write them down and check it that way, or can I just think of that in my head and try the different combinations in my head? Absolutely. If you can figure that out in your head without actually writing it down, you can try the different combinations in your head. Go right ahead and do that. Go right ahead in your head and do that in your head. That's fine. All right. Fourth example now. Solve x squared plus 7x equals negative 10 by factoring. So how do we solve something by factoring? If we were to graph this as a parabola, you could make an XY table. It potentially could cross the x-axis. Don't write this down for me. This is just a side note. But it potentially could cross the x-axis. It could be nothing like that. It could be one time. It could just touch it, make a tangent point, and come back up. Or it might cross in two different spots. Factoring allows us to find either those two spots, this spot, or the fact that it doesn't have any real number solutions. And so that's what we're finding by factoring, where it crosses the x-axis. What are the values of x, in other words, that make the y value 0, or would make the graph equal to 0. So we need to get one side equal to 0 to do that. So let's show this in our different color. Add 10 to both sides to start. You always need to get one side of the equation equal to 0 when you are solving by factoring. So we have x squared plus 7x plus 10 equals 0. So let's make a little note off to the side here that you must get one side equal to 0 first. That's when you're solving by factoring. And that's exactly what we're doing here. So at that point, now we try to factor it. Now we try to break it down. If you want to use the magic X, you can. I'll do that off to the side. So let's do that here together one more time. If you are successful doing this kind of stuff without the magic X, go right ahead. So we're saying though the product is 10 and the sum is 7. Last number goes on top, middle coefficient goes there. So what two numbers are going to multiply to 10 and add to 7? Well, I think that's pretty straightforward. I hope it is. 2 and 5 is going to be the right combination there. So we're going to take these numbers and they're going to get plugged in right here and right here. So this becomes x plus 2 times x plus 5. Could I write x plus 5 times x plus 2 instead? Sure, absolutely. And so now it's the 0 factor property, where if this part right here, x plus 2, if that whole thing was equal to 0, you would have this set of parentheses would be 0 times, who cares what that is, 0 times anything is still going to be 0. So that would make that true if this whole thing together, if x plus 2 was equal to 0. Likewise, if x plus 5 was equal to 0, that would make this whole set of parentheses equal to 0, and 0 times, who cares what this would be, 0 times that would still be 0. So this is the 0 factor property. We are saying from there then that either you can basically split this in two parts, and you can say this either equals 0 or this equals 0. So either x plus 2 equals 0 or x plus 5 equals 0. Now I'm guessing a lot of you can just look at that and say, well, I know what would make that 0 and this one. For right now, show the steps, but if you want to skip these steps, these are really easy, I think, to do in your head. To just say this one would have to be negative 2 and this one would have to be negative 5. Yes, that's true. But sometimes you have these more complicated terms there. You have fractions to deal with, especially if you have coefficients in front of the x's here and here. That's when we deal with the fractions. So this is one possibility. X is equal to negative 2, or you've got x is equal to negative 5. Those are your two possibilities here. You plug either one of those back in up here, you're going to get a true equation. So let's do that mentally real quick. We'd have negative 2 squared would be positive 4, and then 7 times negative 2 would be negative 14. 4 minus 14 would be negative 10. So that one works. That one checks. I'll write a little check next to that to denote that we checked that in our heads. This one would be negative 5 squared, 25. And then you have negative 35, or 25, positive 25 minus 35. That is also negative 10. So that checks out as well, and we're good to go from that point. So it checked both spots. Now we're checking out example 5. So now we're going to start using something different here. So let's solve x squared plus 4x minus 32 equals 0. This next step, don't write this down. What I'm about to write down, just listen for right now. But if you tried to factor this, factors of 32, you could have 1 and 32, you could have 2 and 16, 3 wouldn't work, 4, that would be 4 and 8, so you could try that. You could try all these different combinations. You'd have to have a plus sign in one spot and a minus sign in the other spot to get a negative product like that, but you could try all the different combinations. You could keep trying and keep trying and keep trying, and you would actually get an answer. There would be one that would be true. So if we kept trying, trial and error eventually would get us to the fact that this would be an 8 here and a 4 here. If we did that, we could solve this by factoring. Sometimes it's going to work out that way. However, we're not going to solve this one this way. So we're just going to note right now that the answer would be negative 8 and positive 4. Notice I said by trial and error. Could you have used a magic X there too and done negative 32, positive 4? Yeah, but it's still essentially trial and error. You're still looking for the combination that multiplies to that and gives you that. However, on this one, so our answer should be negative 8 and 4. That's what we think, at least at this point. I'm going to say we need to solve this one by using the quadratic equation instead. And so sometimes you just get stuck. You don't see what the answer is. You can always fall back on the quadratic formula, is what I should call it, the quadratic formula. This is in the form of a quadratic equation right now. I could have made my eraser bigger there and done that very much more quickly. Could have done that quicker, but oh well, it's done, it's gone. The quadratic formula. So solve this by using the quadratic formula. So let's verify that the quadratic formula gives me the same thing that factoring would have given me, which we determined was going to be, I think we had negative 8. Yes, we were going to have negative 8 as a solution and positive 4 as a solution. So what is the quadratic formula again? This is big. Let's write this down pretty big. Quadratic formula. When you've got it like this, you've got this ax squared plus bx plus c format. You're going to have x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Where this equation comes from is actually from completing the square. If you remember something called completing the square, we're not doing that here in this lesson, but you can prove that that is true using completing the square. However, that's beyond the scope of what we're going to do here in this lesson. Just remember the formula. If you've heard of Pop Goes the Weasel, I'm going to sing a little bit right now. I know you're scared, but that's okay. You'll be okay. Just cover your ears if you need to. So, Pop Goes the Weasel. That tune, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Yeah, that's going to get repeated as I go through this lesson here. That song, it's coming back. It's making a comeback. So, let's rewrite what I have here. And determine what's a, b, and c. So there is no number written in front of the x squared. That means it's like there's an invisible 1. Let's put that in our different color. This right here is going to be my a value. Right here is my b value, the part along with the sign in front of the x part. And then my c value is the plain old number all by itself. So the c value is right there. So from there, we tried factoring. It actually worked in this case. Sometimes it's not going to work, and sometimes it will work. But if you don't know if it's going to work, or if you're not told which way you have to do the problem, the quadratic formula always will work. It will always tell you how many solutions there are and what they are, if there are in fact solutions. So with that being the case, you have x is going to equal, we've got it in this form that we needed, in this ax squared plus bx plus c form. And I think that's important to note here. This only works with the ax squared plus cx plus bx plus c equals 0 form. So you got to get it in that form first. If it's not in that form first, you got to change it so that it is in that form. So here we have x equals negative b, negative 4, plus or minus the square root of b squared, 4 squared, minus 4ac, minus 4 times 1 times negative 32, all over 2a. That's all over 2 times 1. Woo woo. All right, so we got the setup. We're good to go with that. Now we have negative 4 plus or minus the square root of 16. You'll have a negative times a negative here and a positive here. So negative times negative will make a positive. 4 times 1 is 4, and then 4 times 32, that's going to give me 128. So I have that all over 2 times 1 is just 2. So from there, let's continue to simplify. This is like it's in invisible parentheses here and here, so we need to combine those things together. First, let's put parentheses there. So act as if there are parentheses there. Put those in a different color. We've got 144 when we combine those things together. Notice I still haven't divided everything by 2 because I'd have to have an outside the radical number here. I can't divide a radical part by a non-radical part and expect that to work out like it should. And so the square root of 144, though, is a perfect, not a perfect number. There's actually, perfect number is another interesting mathematical concept, but this is a whole number. This is a whole number. Perfect number is, how did that go again? It's something about all the factors of the number. When you add them up, add up to the number itself. So 6 is a perfect number because 1 plus 2 plus 3 is 6. So you're taking all the factors of the number except for the number itself. I think 28 might be the next perfect number. Yeah, pretty sure 28 is the next perfect number because you got 1, 2, 4, 7, and 14 all add together to get 28. Perfect. Beautiful. But this is a whole number. That is totally off topic. I'm sorry. Not that sorry, though. Math is cool. So we have negative 4 plus 12. That's one option. Negative 4 plus 12 over 2. And that would be, negative 4 plus 12 would be 8 over 2. Or, so plus or minus. Take that literally, plus or minus. We have the plus option right here, or the minus option. Negative 4 minus 12 is negative 16 over 2. And that would equal 4 or negative 8. So just like we thought it would be, we thought we were going to get negative 8 and 4 by factoring. This one happened to factor out nicely, but quadratic formula also worked out here. So let's make a little note of that, that yes, it would have factored. This one did factor. Sometimes they don't. Sometimes we have to use the quadratic formula, but this is a fallback, a fail-safe, you could say, something that will always work. So factoring, let's make a note of this, factoring would have worked here as well. But the directions, I'll read the directions. What? I have to read the directions, Mr. Wagner? Yeah, that's probably a good idea. So, but the directions stated to use the quadratic formula. So, do what the directions say to do, and you do things right then. You won't get in trouble. Time for example 6 now. So example 6, let's solve this. Solve 12x squared minus 33 equals 14x. So I've had some students in the past do this. I know you're not going to do this because you're going to learn from their past mistakes that's what history's all about, right? We learn about history so we can not repeat the mistakes of our ancestors, of those that came before us. Yeah, let's do that here. Let's make sure we don't just call this A right now, this C, and this B. We have to get it in this form first. You have to get it in ax squared plus bx plus c form first. And so let's do that here. To do that, we would just need to subtract 14x from both sides. That would get that to cancel out here and here. And bada boom, bada bing, you got 12x squared minus 14x minus 33 equals 0. Now it is in that ax squared plus bx plus c form. So from here, now we could try to factor. So I'm not sure if this is going to work yet. Don't write this down, but let's just think about it. So we'd have lots of combinations here. 1 and 12, we'd have 2 and 6, we'd have 3 and 4. And over here, 1 and 33, and 3 and 11. We could have that. We could flip-flop any of those things too. We'd have a minus sign here and a minus sign here. You could try combinations all day long on this one. You could try them all the possibilities, and nothing would work out. Notice I did not tell you how to solve this one. So could you use the quadratic formula? You sure could. And that's what I'm going to do here. So if you didn't use that and you tried factoring, you would have tried in vain. It would not have worked. You would have just kept trying and trying. You'd have probably wasted 5 minutes trying to do that. So quadratic formula time instead. This is going to be my A, this is my B, and this is my C, the negative 33. So make sure you include the signs with those things as well. That's very important when we plug it into the quadratic formula. So we have this, we've got that in the ax squared plus bx plus c form. So now we can plug it in. X equals negative b, that'd be negative 14, by the way. So the opposite of what b is, negative of negative 14, plus or minus the square root, that is negative 14 squared of b squared, minus 4ac, all over 2a. I don't even know the actual words to Pop Goes the Weasel. It just ends, Pop Goes the Weasel. Is the weasel coming out of a Jack-in-the-Box or something? What the heck? Where do these songs come from? Why do I know them, but don't know them? I don't actually know the words. So I have positive 14. This will change to positive 14. This would become 196, positive 196, negative times negative. You've got a negative here times a negative, so that will be positive. 48 times 33 ends up being 1584. And I went a little too far with my square root symbol. I don't need to go quite that far. There we go. And this is going to be all over 2 times 12, all over 24. Combine these two things together, and we would have 1780 right there. Got that over 24. And then from here, I want to get exact form and approximate form. We need to get in the habit of doing that. So I'm going to try some different numbers and see what factors into 1780. See what goes into there evenly. So 1780, trying different perfect squares. 2 squared is 4. So I'm going to try dividing this by 4. And I get 445. So I know that is one possibility, 445. I could try other numbers, other larger perfect squares. So 1780 divided by 9. Is that going to work? No, it didn't give me a whole number. So I'll try another one. 1780 divided by 16 would be next. Is 16 going to work? No. I divided by 4 before and saw that it was going to be this 445 number, and 4 wouldn't go into there. So that's another way I could have determined that 16 wouldn't have worked. 25, is that going to work? It does end in a 0, so maybe, but no. It's got to end in 75 or 50 or double zeros, or a 75. I already said that, 25. So 1780, we could keep trying different numbers. 36, we could try that. I should try that next. 36, nope, not a whole number. 1780, divide that by 49. You could keep trying different numbers. The biggest perfect square though that's going to work is 4. All right, so we try to get the biggest one possible. We already got to something over the divisor, the thing I try to divide by 49, so I really don't need to go any farther there. So I've got 4 times, it was 445. So a perfect square that divided evenly into 1780, the largest one was 4. So 4 is the largest perfect square. If you learn something like this instead, though, I'm not going to have you write this down. This is just to remind you. If you learn of doing stuff like this instead, factor tree way, 2 and 2, you could split this up into 5 and something, I don't know what's going to go there. Perhaps you could split that up farther. You look for pairs that go in there. That's the other way to do this. I tend to like this way better because I can just, as long as I can use a calculator, I can check things easier. I think I can do it more quickly that way. So 4 is the largest perfect square. And then let's write e.g. for example 4, 9, 16, 25, 36, etc. So it's the largest perfect square that divides evenly into 1780. So that's our side note there. And then this 4, what is the square root of 4? Well, it's 2, so I can replace this. I'm going to have this over 24, sorry. Don't forget about that. So you have 14 plus or minus. This can come out. The square root of 4 is 2. The 445 is still hanging out inside there. But the 4 comes out as a 2. Because the square root of that is that. So let's make a little note of that quick. That's where this came from. It's because the square root of 4 equals 2. And so from there, we can reduce this. I can reduce each part by 2. I can make that a 1. I can make that a 12. I can make that a 7. And so this reduced now becomes 7 plus or minus. If it's just a 1, I can leave that out. Plus or minus 445, radical 445, over 12. This would be my exact answers. There's actually 2 answers there. You have the plus and the minus right there. So these are exact answers. Let's make a little note of that underneath in our different color. So these are exact answers right here. And then let's approximate those values. If I did 7 plus the radical 445 over 12 part, that would give me, for time's sake, I'm just going to tell you that I did this before I plugged it in. That would give me 2.34 to the nearest hundredth. And then 7 minus the radical 445 over 12 would give me approximately negative 1.17. So these are approximate answers instead. So right here, just depends on what they tell you to do. If they tell you to give exact answers, leave it like this. If they tell you to give approximate answers, put it like this instead. So approximate answers are here. And then a final note to make. I feel like we've done a lot here in the notes, a lot of different variations. They do an example in the book, a couple of examples in the book. Is it actually 3? No, it's 2. I think it's 2. No, it's only 1. It's only 1. But they do an example in the book that is a real-life situational problem. And so I want you to actually go there. Let's do that right now. Go there and read that if you're one of my students. For help with number 79, when I will have you do that one in the classwork most likely, 79, you should first read example 12 on page 359. And go put an exclamation point there. That's not 359 factorial, smart aleck. That is just 359 emphasis, important. So a little note here, a little helpful tip. That one, it is a real-life application of the type of things we're doing here, where you actually get to use either factoring or the quadratic formula to figure out something that applies to a real-life situation. And that'll do it for me. I hope you found that helpful. If you were reviewing some algebra concepts there, hopefully you caught some stuff in a clear way that maybe you didn't get so well before. If that was your first time with factoring and things of that nature, hey, I hope that was helpful for you. I tried to do an example of each of the major types that you'll see. There's, again, if you're one of my students or taking the CTM class here, you've got 12 other examples in the book to look at to refresh your memory on factoring and quadratic formula things. All right, have a good night, day, afternoon, whatever time of night it is or day it is for you, and I will catch you guys later.